So today we're going to add in one more form of an equation of a line called symmetric equation. First, let's recap our other two that we know. So we've got a line passing through the point A and direction vector M. So let's do our vector equation first. So we know that our point on the line is going to be equal to our fixed point plus some scalar multiple of our direction vector M. Now, we need our parametric equations. Parametric equations. So here we're going to take our vector equation and break it down into the equation for our two components. Now, symmetric is we're going to take our parametric equations and we're going to rearrange them for t and then set them equal to each other. So rearrange each equation for t and set them equal. So our first equation, x equals 1 plus 2t, rearranging that for t is going to give us t equals x minus 1 over 2. And for y, rearranging our equation for y, or rearranging our y equation for t, is going to give us t equals y minus 1 over 3. Now we can set them equal to each other. X minus 1 over 2 is equal to y minus 1 over 3. These are the symmetric equations. Hopefully you notice that on the bottom of the x part is the x component of the direction vector. On the bottom of the y component is the y component of the direction vector. And then on the top is x minus 1 and then y minus 1, which comes from our position vector. So let's look at the general form. If A is a fixed point on the line with direction vector m1, m2, let P be any point on the line. And then the symmetric equation of the line is this here. X minus a1 equals y minus a2 over, respectively, m1 and m2. Now note that m1 can equal 0 and m2 can equal 0. If you have that, the symmetric equations of the line just don't exist. Doesn't mean the line doesn't exist, but the symmetric equation version does not. So let's find all three equations for the following points. So our first thing that we need is our direction vector, since we're given 2 points. So our direction vector is going to be AB. Okay, so that's easy enough. 5 take away 1, 4 take away minus 3. And so our direction vector M is 4. Whoops, I wrote those coordinates incorrectly. Let's try that again. Okay, so our direction vector, we've got our x coordinates first. So we've got 4 take away minus 3, and then 5 take away 1. This gives us a direction vector of 7, 4. Now, we can write our vector equation of the line using a point. So let's use A. You could use B, just a different version of the equation. And then our direction vector. Next, we can write our parametric equations by breaking them down into their x, y components. So we've got x equals minus 3 plus 7t. And then we've got y equals 1 plus 4t. And finally, we'll add on our new one, the symmetric equations. And our symmetric equations, we're going to rearrange and set them equal to t, or you can use the formula. We've got x plus 3 over 7 is equal to y minus 1 over 4. So again, either rearrange the parametric equations for t, or you can put them into the formula of x minus a1 over m1 equals x minus a2 over m2. Hopefully you're thinking about how you can extend this to 3D. Okay, another example here, we're going to find all three equations. Now we're given an equation in slope y-intercept form. So first thing we need to figure out is our direction vector again. So we know that our slope is 1 over 2. So this means that our direction vector we can write as run 2, rise 1. That would be equivalent. And we can use our point on the line as 0, 3. You could find any other point on the line that satisfies that as well. So we'll start with our vector equation. We have xy equals our point 0, 3 plus t times our direction vector. Then we can extend that to our parametric equation. By breaking them down into their individual components. So x equals 2t and y equals 3 plus t. Finally, we can write our symmetric equations by either rearranging our parametric equations for t or using the formula back on the third slide. When we do that, we get x over 2 equals y minus 3 over 1. So let's do one more example. Here we're given our information in a different way. We've got a direction vector and we've got a point. So we can jump right into our vector equation by starting off with xy is equal to our point 1 minus 1 plus t times our direction vector. Great. Then we can write our parametric equations by breaking them down into their components. X equals 1 minus t, y equals minus 1. Then we can try and write our symmetric equations. Hopefully you're seeing what is going to be a problem coming up here. If we try and rearrange those, we get t equals 1 minus x, no problem, but we just get that y equals minus 1. We can't rearrange that for t, so our symmetric equations just don't exist. And that's okay. So I'm going to pause it there, and I'm going to post the last 2 slides in another video. Okay, but this first part of the video is all about being able to find the vector equation, the parametric equations, and the symmetric equations of a line in 2D.